Good day, class. So here's the continuation of our discussion regarding fats and oils, or what we call triacylglycerides. So it's Sir Gavistrano again, and welcome back to Chem 21 Organic Chemistry. So for this discussion, I will be using whiteboard. This is so bilis siya. So for this one, we will be tackling our reactions of fats and oils. And there are actually three main reactions that we need to consider when we are talking about reactions of fats and oils. So, bali, tatlo kasi one of the reactions that we need to tackle is the reactions of the fatty acid residues. It means ito yung nagpo-focus lang sa mga reactions dun lang mismo, dun sa mga fatty acids, not mismo ron sa fats and oils. Ibig lang sabihin, it will be the reactions that are focused on our fatty acids, uh, yung ating lauric acid, myristic acid, oleic, linoleic, and linolenic. So, and we have two other reactions wherein yung reactions naman ay doon naka-focus mismo ron sa property na yung ating triester. Wherein by property ng triester, we will be looking into ano ba yung effect kapag nilagyan natin ng highly basic or nilagyan natin ng tubig yung fats and oils. So, yun yung titingnan natin. More on nakafocus yun dun sa glycerol at saka dun sa ating mga acyls or yung mga ating mga carboxylic acids or for this discussion, yung fats and oils. So, first, we need to look into the reactions of the fatty acid residues. There are actually two reactions that were in yung fatty acid residues natin na involved. Yung unang reaction natin is yung tinatawag nating halogenation. This is not actually new sa inyo kasi when we talk of halogenation, this is just the addition of halogens. Ano ba yung mga halogens natin? Ito yung fluorine, bromine, at saka yung ating iodine. Ano? So, by hydrogenation naman, again, hindi na ito rin bago sa inyo. Ito actually is more on the addition of our hydrogen to the fatty acid. So, by that, kung makikita nyo rito sa general form nung reaction, it only happens on the double bonds. So, basically, the reaction of fatty acid residues actually only happens on our unsaturated fatty acids. Ibig sabihin, kung mapapansin nyo, isa to rin sa mga naging dahilan kung bakit sinasabi nila na mas healthy yung ating unsaturated fatty acids kasi mas nagkakaroon tayo ng reactions papunta doon. Kumbaga, yun yung isang pwede nating tingnan when we talk about those unsaturated fatty acids. So, like any other halogenation reaction that we have encountered in this class, we will be just adding halogens. And in that note, we will be just severing the pi bond of the double bond. So, ang mangyayari, kung meron kang ganyang reaction at nandyan yung iyong mga nasa double bond na carbon, we will only have here a reaction wherein we will have a syn addition wherein nasa magkaibang side yung ating mga halogen. So, ganyan yung nagiging reaction when we have halogenation. So, kumbaga, kung meron kang tag, let's say for example, we have this tag. Let's just copy this first. For this tag, as you may notice, we have two acyls that are actually having those double bonds. And in that, ibig lang sabihin yan, doon lang mag-occur yung reaction natin. So, kumbaga, if we just consider this bond or this tag, tapos, let's say, meron tayong halogen, say iodine. So, ano bang iodine? That is just I. Sorry about that. Tayo. Say we will be adding iodine here. So, for that, hindi pare-parehas yung reactions na mangyayari. Depende rin sa number of moles ng halogen na gagamitin natin. So for example, I just added 1 mole of our iodine here in the presence of carbon tetrachloride. Tetra, so that means 4. So in that, in here, kung makapansin niyo, 1 mole lang yung ating iodine. So ang mangyayari, for this reaction, itong iodine, it will either have a reaction with this double bond or this double bond. So basically, if you have here a tag na may dalawa yung may double bond natin, magiging dalawa yung products natin. Dalawang products in which yung tag, yung isa ay ano siya, dihalogenated siya, or yung isa yung magiging dihalogenated. So for this one to be completely halogenated, ang pwedeng gawin natin, we need to increase the number of moles of our hydrogen. And for this case, we will be having 2 moles of our iodine. So given that, ang gagawin na lang natin dyan ngayon, we just need to conduct scene addition dito sa ating double bond na ito, wherein masiserver yung double bond. Magkakaroon ka ng isang iodine dito sa itaas at isang iodine dito sa baba. So in that, you need to count the number of carbon atoms na present dito para masigurado mo na tama rin na same na tag or same na carboxylic acid yung mapapag-addan mo. So, you just need to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So, ang gagawin mo ngayon, you just need to copy the glycerol. Mas mapadali tayo. Let me just copy this part. Mhm. Okay. Medyo nagkakaroon ng glitch yung But anyway, we will be just moving this. Lang natin siya. May nadalang dalawa. I-count natin yung later. Okay. So what will happen here, class, is we just need to uh, rewrite the 18 there. So we have there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then you need to account kung ikailan ba to. Usually that is nasa 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So dito yung isang iodine natin and dito yung isa. So similar scenario will happen to the second acyl here. So, ganun lang ulit. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Pare naman kasi 18 yan. Ano? Check lang natin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, bawasan natin. Okay, so that is 16. Nasa 9 ulit yun. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So dito ulit siya. Iodine natin at dito yung isa. So as you may notice here, natanggal natin yung double bond with doon sa ating glyceride. So, that. Ayun yung pakapin ng maayos. Anyway, so just need to copy this kasi walang mangyayari dun sa ating glyceride na walang walang double bond. So, that will be the halogenation of our triacylglyceride there. So, ang nangyari lang, kinat lang natin yung double bond dun sa ating 6 na double bond. So, nawala yung pi bond niyan, then inad lang natin yung mga iodine natin. So, baka nagtataka kayo, sir, ano nangyari din sa carbon tetrachloride? Tetrachloride here is non-reactive para dun sa triacylglyceride natin. It acts more like a reagent or yung tinatawag natin catalyst. Okay? So that is the halogenation part of our reactions on fatty acid residues. So another reaction that we need to consider when we are talking about fatty acid residues is the hydrogenation. So by hydrogenation, we will be just adding hydrogen here. So, as you may have remembered, kung meron tayong double bond, dinagdagan natin ng hydrogen or in any case, kung meron kang alkene, nilagyan mo ng hydrogen, magiging lang siyang alkane. So, similar scenario ang pwedeng mangyari dun sa ating mga unsaturated fatty acids kung meron silang double bond. Siyempre, unsaturated fatty acids sila, so meron silang double bond. So, in that note, upon hydrogenation, matatanggal lang natin yung ating double bond. So, but for this one, it actually, hydrogenation of fatty acids actually occurs in the same way with other hydrogenation na kailangan natin ng catalyst, usually metal catalyst, and for this scenario, we'll be using nickel. And there is also one special condition kung paano ito mag-occur. Kailangan meron tayong mataas na pressure, and by mataas na pressure, that pressure may exceed, yung pressure na dapat i-maintain ay yung 20 hanggang 40 psi. So, as you may have imagine, medyo mataas na pressure yan. So, ang mangyayari dito, when we have hydrogenation, what will happen here is we will have here an addition na parehas yung side na pupuntahan ng hydrogen natin. Okay? So, as usual, parang yung sa alkene lang, ganyang reaction din yung nangyayari when we are dealing with hydrogenation. So, para dun sa same example na ginamit natin kanina, kung yan ay mag-undergo ng hydrogenation, let's say we have here hydrogen under 20 to 40 psi in the presence of nickel. So, ganun lang din ang mangyayari. Ano? This 18 chain, matatanggal lang yung double bond. This 16 chain, matatanggal lang din yung double bond. So, in that note, you just need to copy lang natin ito. Okay? So, dyan, we just need to add yung chain mismo. So, dahil doon, sa presence ng ating hydrogen, let's say that hydrogen is in excess, what will happen here is we will have here a reaction by excess, sobra-sobra siya, na magiging lang siyang straight chain. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright? Then 16 naman yung dito. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then mareretain pa rin yung nasa baba. We can just copy that. Okay. So let's just move this. So ganyan yung magiging reaction. So, in that note, kailangan lang tandaan class na whenever we are dealing with reactions of fatty acid residues, ang yung halogenation at hydrogenation natin ay nangyayari lang dun sa ating mga uh, mga fatty acids na unsaturated. So kapag saturated yan, meaning to say wala tayong double bond, walang mag exist na reactions. Kailangan lang din nating tandaan, class, dapat yung moles or kung ilang moles yung idadagdag natin na ayun na halogen or ilang moles yung hydrogen na idadagdag natin ay dapat kasing dami or in excess doon sa ating number ng double bonds. So halimbawa, dun sa first example natin, since dalawa yung double bond, kailangan 2 moles yung iodine na i-add natin. Kasi pag hindi 2 moles ng iodine yung inad natin, isa lang doon sa mga na yun, sa double bonds na yun, yung pwedeng ma-halogenate. So, in that, magkakaroon ka ng dalawang magkaibang products. Okay? Yung isa, dun, yung ang nagkaroon ng halogenation ay yung nasa pinakataas, yung 18 or pwedeng yung 16 naman sa baba. Okay? So, those are the reactions of fatty acids residues. Meaning to say, by fatty acid residues, this reaction only happens in our unsaturated fatty acids. So the next reaction is actually the sulfonification. By sulfonification, this is just the addition of our sodium hydroxide to our tag. So ano ba nangyayari dito kapag meron tayong saponification? So basically, for saponification, what happens is dahil dun sa presence ng hydroxide natin dito sa ating NaOH, nakiklive, nagkakaroon tayo ng pagkaputol ng reaction natin or pagkaputol ng bond natin between yung sa glycerol natin, yung sa carbon na ito at saka dito sa oxygen ito. So, yun yung kailangan natin consider regarding sa saponification. And this saponification is actually an ionic reaction due to our sodium hydroxide itself. So, basically, dahil dyan sa kasi sa sodium hydroxide, ang sodium hydroxide, kung naalala nyo, ang sodium natin ay actually positively charged and negatively charged naman yung ating hydroxide in aqueous form. So, ganun yung treatment na mangyayari dito sa ating saponification. And in that case, ang nangyayari kasi sa saponification ay ganito. So, copy lang natin itong tag na ito. So, hindi naman siya nakisama. Move natin ng kaunti. So, basically, for this reaction with NaOH, ang sabi ko nga kanina, nakakat yung bond natin between the glycerol oxygen and a glycerol carbon dioxide, and pumapasok yung ating ano diyan, yung Na at saka yung OH. So ano ba yung nagiging product natin dito? Basically, if we have this reaction, what happens is, yun, nagkakaroon tayo ng deassociation ng ating glycerol at saka ng ating mga ethyl. Tapos, dahil doon, magiging negatively charged actually itong ating oxygen dito. So, negatively charged ito, negatively charged ito, negatively charged ito. Then, yung OH natin, it will actually bond. Yung OH galing dun sa ating sodium hydroxide. So, para maging mas malinaw doon, isulat natin siya gamit ang ibang kulay. So, halimbawa, let's say we have here our NaOH. Yung NaOH na mag-a-attach dun sa ating glycerol ay actually yung NaOH na galing dun sa ating yung OH, yung hydroxide na galing dun sa ating NaOH. Then, what will happen here ay yung ating Na o yung ating sodium, sabi natin kanina ay magiging positively charged yan, and it will be attracted to this negatively charged oxygen. So, yan yung mga magiging product natin. So, we have here this glycerol and this sodium salt. And kung familiar kayo sa sodium salt, ito yung ating glycerol, ito yung ating sodium salt. Ang sodium salt, actually class, ito yung tinatawag natin soap. Okay? So, ganyan yung process ng paggawa ng ating soap. Basically, meron ka lang oil. Okay, oil or fat. Yung oil or fat na yon, ano mo siya, i-expose mo siya sa sodium hydroxide. Merong siyempre heat na involved dito para mapabilis yung reaction na ito para dun sa formation ng ating glycerol at saka ng ating sodium salt. And that heat actually removes the presence of the glycerol in your soap. So kapag ito, yung sodium salt nagsolidify, meron ka ng sabon. Bala ko sanang gawin to dito sa klase natin para pang project natin sa dulo. Pero tingnan natin kung anong mangyayari. Ano? Kasi iniisip ko yung iba sa inyo ay galing sa malalayong lugar. So hindi ko alam kung paano kayo magkakaroon ng sodium hydroxide. Kasi syempre, ang sodium hydroxide ay hindi ganun ka-usual na chemical. So, in that, we have here this reaction of sulfonification. So, let's try dun sa example na ginamit natin kanina kung paano ba yun mangyayari. So, using the same example na ginamit natin kanina, and we will be adding our sodium hydroxide. Gawin natin yung kulay niya. Kasi, gawin natin siyang NaOH na rin. So, what will happen here? So, kopyahin lang ulit to, yung buong yan. Yun lang naman yun. You just need to copy that whole tag. And for my case, napalayo yung copy. But anyway, pwede naman din. Isolate ko na tong ating glycerol. Burahin ko muna itong ating mga tapos, lagyan natin ng negative charge itong ating oxygen dahil dun sa server or dun sa cleave. Then, we will be adding our OH here na nanggaling dun sa ating hydroxide or dun sa ating sodium hydroxide. And we will be adding our Na here. So, this is Na plus. Okay? So, that is sulfonification. So, pakita ko lang ulit ng buo para makita. So, this is our sulfonification. Okay? So, for the less reaction ng ating triacylglycerol, we have here our hydrolysis. And by its name, hydrolysis, it is just the addition of our water. So, hydrolysis actually related ito sa energy formation galing sa ano natin, sa mga fats sa katawan natin. This is how energy is released from the fats that is stored in our body. So as you may have remembered kasi, di ba, when we are talking about metabolism ng katawan natin, pag naubusan ka ng carbohydrates, yung next na naiko-consume ng katawan mo ay yung fats. Yung paano nangyayari yun? That is through the process of hydrolysis. Pero dun sa katawan natin, syempre merong special na hydrolysis na present na nangyayari. Yan ay through enzymes, meron pang mga tawag dito, pathways na kailangan sundin. But basically, if we are just to talk about the hydrolysis part, ganito siya nangyayari. So, by hydrolysis is nung ating triacylglycerol, baliktad yung nangyayari dun sa reaction natin. Imbes na yung bond ng glycerol, carbon and oxygen yung nasa-sever, ang nasa-sever natin ay yung ester bond in between our fatty acids and yung glycerol mismo. So dito siya sa mga nilagyan ko ng red. So basically, gawin lang natin ulit yung ginawa natin kanina wherein magkakaroon lang ulit yan ng cut dyan sa portion na yan. So, basically for hydrolysis, in the presence of water, what will happen is, yahin ko lang ulit ito. Then, as I had mentioned earlier, ayun nga, magkakaroon tayo ng pag-sever ng bonds dito sa mga tao. So, what will happen here is, matatanggal itong mga bond na ito. Let me just write some of the code. Then, magkakaroon tayo ng ganitong product. So basically, as you may have remembered, sa hydrolysis, may dalawang parts yung water natin. Yung acidic part at saka yung ating basic part. Ano? Siyempre, lagi naman ganun yung ating acids and bases wherein we have here the H plus and the O minus. So, ano mangyayari dito sa H plus at sa O minus na ito? Basically, in hydrolysis, what will happen is we will have a formation of glycerol na wherein yung hydrogen ng water natin ay doon mapupunta sa glycerol part. And we will have here our fatty acids wherein dito naman mapupunta yung ating negative part yung ating mga hydroxide. So, basically again, we have here our glycerol and we have here yung ating tatlong fatty acids. So, that is our hydrolysis. And dun sa example natin kanina, similar yung magiging approach. Ano? So, when you add water to this triacylglyceride, ganun lang ulit, you just need to sever this bonds, yung mga yan. So, para makuha mo yung result ng yung hydrolysis. And this reaction actually releases what we call energy. So, what will happen here is we will just copy this tag. Then, what will happen is, yun nga, magkakaroon tayo ng server dito. Yung server yung bond na yan. So, ang gagawin lang natin, matatanggal itong mga bond na ito. Okay? Then, we will have here, we will have here our hydrogen here. So, dun sa ating nakat na ester. Tapos, andito yung ating mga hydroxide dun sa ating mga fatty acids. Okay? So, that is how we hydrolyze our triacylglycerol. Okay? So, balikan lang natin ulit yung mga reactions. So, yung unang reactions natin or set ng reactions ay yung ating reactions of fatty acid residues wherein ang dalawang reactions natin and dyan yung halogenation at saka yung hydrogenation. So, dito, nangyayari yung reaction dun lang sa ating mga alkene part or dun sa ating mga double bonds. So, nagiging straight chain lang siya na wala tayong na-saturated. But hindi ko sure kung matatawag ba natin saturated kapag iodine na yung naidagdag natin. So, another reaction is our saponification or salt formation, as other may say. So, ang nangyayari naman dito, in the presence of sodium hydroxide, nagkakaroon tayo ng formation ng glycerol at saka yung ating sodium salt o yung tinatawag nating soap. So, dahil yun dun sa presence ng ating sodium hydroxide or yung ating NaOH. And yung last na reaction natin naman ay yung sa hydrolysis. So, by hydrolysis, this is just the addition of water to our triacylglyceride, producing glycerol and fatty acids. So, in that, that's all regarding our discussion regarding fatty acids or by fatty acids, fats, and oils. So we are actually nearing the end of our discussions. Meron na lang tayong dalawang main topics na kailangan natin i-discuss. Pero yung last topic ay medyo pinag-iisipan ko pa kung dadagdag ba natin. But for next meeting, we will be actually talking about amines or the organic derivatives of ammonia. Tapos tayo sa organic derivatives of water. So, doon naman tayo sa organic derivatives of ammonia. So, and lastly, yung ating amino acids and peptides. So, for amino acids of peptides, depende pa kung aabot tayo doon. But basically, I will be just introducing the structures of our amino acids and peptides para pagdating nyo sa inyong organic chemistry, hindi na siya ganun ah, kabago or kahirap intindihin. But in that, I will be ending this video here. So thank you and have a great day. Bye.